This is electrostatics concept questions number 31 through number 40. We've already talked a little bit about this when it says the reason a charged balloon will stick to a wall is, and if you remember, we know that there are charges on the balloon which are negative, so that'd be all over the surface, and those pull on the positive charges on the wall. So we say that those are the induced opposite charges. In this case, they'd be positive. And they are much closer than the other charges, which are actually pushed away, because the negative charge here and the negative charge on this side will actually push each other apart, whereas the positive and the negative in the wall and the balloon will attract each other, and that's why you get such a tremendous force between the two. And because electricity is stronger than gravity, that balloon will stay right where it is. The charge distribution in some molecules is permanently separated into positive and negative regions. So we call those molecules dipoles. So if I have water, so here is water, and I have a hydrogen, an oxygen, another hydrogen, the oxygen tends to be negative and the hydrogen tends to be positive. And where we have the difference between the two, we end up having what we call a dipole. So there would be a dipole here, there'd be another one here. The overall dipole would be positive on this side, and it would point this way to the negative on this side. So electric dipole, remember the word di means two, and that should help you a little bit with that question. Number 33. Two charged particles are held close to each other and then released. So here are the two particles. When I let go of them, they will start going towards each other. And because the force gets bigger, you'll notice that this arrow is smaller than the arrow down here. And same thing here, they should be equal because of Newton's third law. The only way this will happen is if they have opposite signs. If they had the same sign, that will not happen. We'll show that to you here in a second. Number 34, two charged particles are held close together and released. As the particles move, the velocity, so this one's different, the velocity of each increases, not the force, but we're looking at velocity. Therefore, the particles have charges that we can't figure out. If I have two positive charges, when I let go of them, they speed up initially. If I have two charged particles that are opposites, when I let go of them, they will come together and they'll speed up until they hit. So it's essentially the same thing. Both of them will increase in speed initially. So we really can't tell what kind of charge either of those has. Number 35, a positive charge and a negative charge are held near each other and released. As they move, we know the force on the two becomes bigger. So there's that little force there, and then here's the bigger force here. So we've done that one before. Number 36, two charged particles are held near each other and released. As they move, the acceleration, notice the term is changed again, of each goes down. Therefore, the particles have, and they would have to have the same sign. If they have the same sign, acceleration is the highest when they're closest together. Then when you let go, they do move apart, but they slow down as they move apart. Initially, they get a really high speed, and then they slow down. Once they separate, they'll slow down, they'll have less acceleration. So they actually have the same side. If you have two particles that have the opposite signs, they actually will speed up as they get closer to each other. So these two, as they move closer and closer, their velocity vectors would become larger and larger until they hit. For number 37, it says the SI unit of charge is the coulomb. That's just one that you need to memorize. That's one of the units that we need to know. For 38, Newton, let's see, it says particle A has twice as much charge as particle B. Compared to the force on particle A, the force on particle B is the same. Remember, Newton's third law basically says every force has an equal and opposite force. So I can only hit as hard as the softest object. So if you remember, we did a thing where we had somebody punch paper, and then we told them to try to punch that paper if it was in front of the wall. And they realized at that time that the paper did not punch back very hard here, but here they would exert a lot more force. That is number 38. For number 39, says if you walk into a region of space and you suddenly feel a force, that space has what we call a force field. If you were able to touch the Van de Graaff generator, you know when you get close to it, you hear that popping and crackling, you actually feel the hair on your arm stand up. So we know that that is a force field. Number 40 is the last one. An electric field has both a magnitude and a direction. If I draw the force field coming from a positive charge, it actually will point out it has a magnitude. So we might say here that this electric field has a certain value, maybe 10, and it has a direction. So it would be pointing up and to the right. And that is questions number 31 through 40.